Here's an example of calculating probabilities from a tree diagram where all of the outcomes are equally likely. Joanna has 2 black t-shirts, 2 grey t-shirts, and 2 red t-shirts in her t-shirt drawer. She has 3 pairs of grey trousers and 3 pairs of black trousers in her trousers drawer. Joanna chooses a t-shirt and pair of trousers at random. So she's got some different t-shirt options and some different trousers options, and she's closing her eyes and randomly selecting a t-shirt and a pair of trousers. And we need to draw a tree diagram showing all of the possible outcomes of Joanna's clothing choices. So for our tree diagrams, we always start with a point, our starting point. We need to decide on what our 2 events are in this experiment. What are the 2 things that Joanna is doing? Well, the first thing she's doing is she's choosing a t-shirt. She's randomly selecting a t-shirt. So I'm going to title our first event as t-shirt. So her first choice is a t-shirt. And then what does she do next? Well, next she randomly selects a pair of trousers. So we put trousers as our second heading. 2 headings. First she chooses a t-shirt, then she chooses some trousers. So there are 2 events, the 2 things that are happening. Underneath our t-shirt section, we need to write all of Joanna's possible choices, all the possible outcomes she has for randomly selecting a t-shirt. She could choose a black one, a grey one, or a red one. Yes, she has 2 blacks, 2 greys, and 2 reds, but her choices are still black, grey, or red. That's the only possible options. So we're going to use the letter B for black. Oh, we have 3 outcomes, so we need 3 branches on our tree diagram. 1, 2, 3. 3 options, black, grey, and red, so 3 branches. 1, 2, 3. Our first possible outcome was a black t-shirt. B for black. Joanna's next possible choice was a grey t-shirt, G for grey. And the third possible choice was the red t-shirt, R for red. She has an even chance of choosing black, grey, or red because there's 2 of each t-shirt in the drawer. So let's consider Joanna choosing a black t-shirt first. If she chooses a black t-shirt first, what are her possible trousers options? Well, she has black trousers and she has grey trousers, so she can either choose black or grey. So because there are 2 choices, we have 2 branches on our tree diagram. B for black trousers, heading's a little bit far over there, but that's okay, and G for grey trousers. It doesn't matter what colour her t-shirt choice is, her trouser choices are always going to be the same. They're independent of whatever her t-shirt choice is. They're not events that rely on each other. The choice of t-shirt doesn't affect the trousers choice. So let's say Joanna chose a grey t-shirt first. Her possible outcomes for trouser choices are, once again, B for black and G for grey. 2 choices, black and grey. And if she chose a red t-shirt first, again, she's got 2 choices, black or grey. The trousers are not changing, the same trousers in the drawer, no matter what t-shirt she chooses. So that is a tree diagram showing the choices, but we need to list the possible outcomes of the choices. So the outcomes come over here on our tree diagram. Outcomes. To fill in the outcomes section, maybe we'll underline these headings so we can see. To fill in the outcomes section, we need to follow the branches of our tree diagram. Let me rewrite trousers so it's in the right place, and then we'll be good to go. Up here, trousers, because these are the trouser choices, these ones here. And then we have our outcomes. So to find the possible outcomes, we need to follow the branches of our tree diagram. Start at our starting point. Our first option is black t-shirt, black trousers. So the first possible outcome is black, black, following those top 2 branches. Then if we follow the black branch again, we have black and grey. So black t-shirt, grey trousers. Black t-shirt, grey trousers. Our next possible outcome is grey t-shirt, black trousers. So grey t-shirt and black trousers. And then we have grey t-shirt, grey trousers. Grey t-shirt, grey trousers. Our next option is a red t-shirt and black trousers. So R for red t-shirt and B for black trousers. Or finally, a red t-shirt and grey trousers. R for red t-shirt and G for grey trousers. Now notice that these outcomes are in line with the final choice on our tree diagram. They're in a straight line. So red, grey, straight across to red, grey. They line up. That's really important to keep our tree diagram nice and neat there. Let's now have a look at calculating some probabilities from this tree diagram. Now, because each of the outcomes are equally likely, we don't need to write the probabilities of each event on the branches. We only write the probabilities on the branches when our outcomes are not equally likely. So all of our outcomes are equally likely because each individual choice is equally likely because there's the same number of each option. So our first probability we want to calculate is the probability that the clothing is matching. So matching black trousers and black t-shirt, matching grey trousers and grey t-shirt. So we have a look at the outcomes where the clothing is matching. So black, black, that's matching. And grey, grey is matching. We have two matching options. So 2 out of how many possible outcomes? 1, 2, 3, 4, 5, 6. 2 out of 6. 2 out of 6 of these outcomes are matching. Matching black and black, matching grey and grey. We always write our probabilities as fractions in simplest form, so that simplifies to 1/3. There's a 1 in 3 chance that the randomly selected outfit will be a matching outfit. Part B asks the probability of something black and something grey. So we're looking for all combinations that have something black and something grey. So here we have, something black and something grey. This one is a combination of the same. Here we have something black and something grey. This combination was black t-shirt, grey trousers, and this was grey t-shirt, black trousers. But we have something black and something grey in both of those combinations. So again, that's 2 out of 6 possible outcomes. 2 out of 6 simplifies to 1/3. So there's a 1 in 3 chance that the outfit ends up being black and grey. Now let's have a look at the probability that the outfit is matching with a dash. Now remember that this dash means not. It's the complement of matching. Every outfit that is not matching. So if we move these out of the way, this outfit's not matching because that's black and grey, 2 different colours. This outfit's not matching, grey and black. This one is matching, grey and grey. This outfit is not matching, red and black. And this outfit is not matching, red and grey. So altogether we have 4 out of 6 outfits that are not matching. And that simplifies down to 2/3. 2 out of 3 outfit choices will not be matching. And our last probability is the probability with black with a dash, which means not black. So we're looking for all of the outfits that don't have anything black in them. So this one has black in it, this one has black in it, this has black in it. Oh, grey, grey. That doesn't have any black items. This outfit has black in it, this one doesn't. No black articles of clothing in this outfit. And so what that means is there are 2 outcomes that do not have black in them. 2 out of 6, which simplifies to 1/3. So when all of our outcomes are equally likely, all we have to do is find the number of favourable outcomes and divide by the total number of outcomes.